In 3 bowling games, Alice scores 139, 143, and 144. What score will Alice need in a fourth game in order to have an overall average score of 145 for all the 4 games? So the unknown quantity here is her score in the fourth game. Let's denote that score by the variable s. So let s be Alice's score in the fourth game. We are given that her average score over all the 4 games is 145. So 145 would be the sum of the scores in the 4 games divided by 4. This follows from the definition of the average of a set of numbers. So here we are taking the average over 4 numbers, and so the denominator would be 4, and in the numerator we would be adding up those 4 numbers. So we know 3 of those numbers: 139, 143, and 144, and the fourth number is unknown. That's what we called as s. So adding s to the numerator, the sum of the 4 scores becomes, and you can work this out, the sum of these 3 numbers would be 426 plus s divided by 4. So if we take this 4 on the left hand side, we would be multiplying 145 by 4 on the left hand side. So this implies that 145 multiplied by 4 is equal to 426 plus s. This implies that this number, 145 times 4, would be 580, because 140 times 4 is 560, 5 times 4 is 20, so adding those two numbers up we get 580 is equal to 426 plus s. This implies that s is 580 minus 426, and this turns out to be 154. So her score in the fourth game is 154. Now there is a simpler way in which we could have calculated the value of s, and to look at that we need to understand a property of averages. Suppose we are given n numbers, let's call them x1, x2, x3, and so on up to xn. The average of these n numbers, let's denote the average by x with a bar on the top. The average of these n numbers would be the sum of those n numbers divided by n. So in this problem, n is 4. We are given 3 numbers, and we are asked to calculate the fourth number. But if you look at the formula for the average score, on the right hand side here you would have 4 numbers. Now if I cross multiply this n with the left hand, if I bring this n on the left hand side, I would be multiplying x bar with n, and then on the right hand side I would have the sum of those n numbers. So let me rewrite this equation again on a fresh page. The sum of those n numbers would be n times their average. So here's what I'm going to do next. I'm going to bring this nx bar on the left hand side. So this would become x1 plus x2 plus dot 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 till xn minus nx bar equal to 0. And we are going to split the nx bar into n copies of x bar. So we're going to say that the sum of these n numbers minus n times their average is 0, and then we're going to split this nx bar into n copies of minus x bar. We will take each of these copies and group them with these n numbers. So we can group the first one with x1 minus x bar. We can group the second one with x2 and so on, and we can group the last one with xn. So what are these quantities? If you were to plot these n numbers on the number line, so maybe x1 is here, x2 is here, x3 could be here, x4 could be here, x5 could be here. We don't know what the values of these numbers are exactly, but assuming they lie somewhere on the number line, x1 minus x bar would be the difference between, or the distance between x1 and the average. So let's mark the average. Let's say the average is here somewhere. x1 minus x bar would be the distance between this point and this point. But because x1 is to the left of x bar, when we take the difference between x1 and x bar, the result would be negative. In fact, the result would be negative for all the numbers to the left of the average. For all these numbers, if we take the difference between any of these numbers and the average, the magnitude of that difference would be the distance between whatever point we are looking at and x bar, but the sign is going to be negative. If you look at the numbers to the right of x bar, the difference between these numbers and the average will be positive because these numbers lie to the right of x bar, and the magnitude of that difference will be the distance between each of those points and x bar. And what this equation is saying is, if you sum up those distances between each of these individual points and x bar, the total will be 0. And this makes intuitive sense because x bar is defined to be the average of all these numbers. So x bar must lie in the center somewhere. In fact, it should lie at a point such that if you add up the deviations of each of these points from the average, they should sum up to 0. This is just another way of saying that x bar is the sum of these n numbers divided by n. We have just rewritten this equation in a slightly different way. So if you take all the numbers to the left of the average and you add up their distances from the average, that sum will be equal to the sum that you get when you add up the distances of all the numbers to the right of the average from the average. But the sign would be negative. So if you add up these two numbers, the result would be 0. But if you just look at the magnitudes, the magnitude of the sum of the distances of these numbers from the average would be the same as the magnitude of the sum of the distances of these numbers from the average. So if we go back to this problem and if we plot these numbers on a number line, here are the three given numbers and the average is given to be 145. So this is where the average lies, and we are asked to find the unknown number, which is the fourth number. Now it's clear that the unknown number should lie to the right of the average, that is, it must be larger than the average because all the other three numbers are smaller than the average, and for the average to lie somewhere over here, the fourth number must be lying somewhere to the right so that the average ends up falling in the middle. Now how much to the right should this unknown number lie? Well, if we add up the distances of all the numbers to the left of the average from the average, we know that that sum must be equal to the sum of the distances of all the numbers to the right of the average from the average. So we know that this distance from 139 to 145, which is 6, plus this distance between 143 and 145, which is 2, plus this distance, the distance between 144 and 145, which is 1, must be equal to the distance between this unknown number s and 145. So this sum is 9, and since s is the only point to the right of the average, we know that s must be 9 units to the right of the average. So this means s must be the average number, which is 145, plus 9, which and that turns out to be 154, the same answer that we got before. Now this might have looked like a longer route considering this calculation we made, but if you bear in mind that the sum of the deviations of all the numbers from the average, taking the negative sign into account, would be equal to 0, and that in effect this is saying that if you add up the distances of all the numbers on the left from the average, that would be the same as the sum of the distances of all the numbers to the right of the average from the average. So if you keep that rule in mind, it becomes easy to solve this problem, because we can calculate pretty quickly that the sum of the distances of these three numbers from the average is 9, and there's only one number to the right of the average, and that's our unknown number. So the unknown number must lie 9 units to the right of the average.